Welcome to the Optimum CAD solution. I am Pankaj Ratnaparki. Once again, we'll start our free online course that is Plastic Product Design and Advance CATIA. So today we are moving towards our next tutorial, which is motor cover or a blower housing design. So for our today's task for this tutorial, we are going to split this total video into the two or three parts, where we are going for 3D design, 2D design, and manufacturing feasibility. So our today's objectives are 3D model design in the CATIA for the motor cover or a blower housing. Then we are going for the draft analysis, then tooling direction and manufacturing methodology, then application of a material. It means where the blower cover is used, that is the application, and what are the material used for manufacturing. Then engineering features to be added for assembly purpose, and then creation of a 2D manufacturing drawing with respect to the application of a GD&T. What are the GD&Ts required to manufacture such kind of a product? So this is our today's task, to design such kind of a cover. So this is only one half of that particular assembly or a particular motor cover. So this cover is used basically to protect the motor, and also it will be sucks the air from this pocket where we provided the ribs for safety purpose. So this air is going to be sucked from here, and that air is forcefully circulated by centrifugal blower. So the centrifugal forced blower is used here, and after then this total suck air is forced by using this cutout, or this is the outlet of our blower housing or a blower. So let's, without wasting time, we'll start for the design. So here we are in the CATIA, and as usual we'll start with the origin, and after then we'll take an axis system. So we'll hide the default planes. So here the axis system, select the origin point, and now we'll start for designing. So we'll start from the sketch here, select the plane, select the orientation whatever we required, and after then we'll enter into the sketch and we'll start for the basic shape design. So firstly we'll take a circle here, we'll draw that total centrifugal force duct area basic shape. So whatever the dimensions you required you can give as per the motor size or the compressor. So such kind of a duct is used in a compressor also to protect the compressed air, to suck the compressed air also, and to protect the parts of the compressor. So here the basic shape we are going to design. So we need to complete that sketch. So we had used 200 mm diameter duct area or that cover area, and the outlet is of 60 mm. So central, so we'll insert the body, we'll give the default name. So the body should be below the part body, so we can arrange that, but we'll take a new body here. So we'll give the basic shape name, or a, this is the basic body, so we'll use as a shape basic or a shape of a blower. So that this line we don't require this one. So here the sketch is get closed. We'll use the pocket command here. So you can see the pocket will use of a 50 mm. Oh, if 50 mm is too much, so 40 mm. Okay. So here the basic shape is get created. So as we know that the blower having one step also, as we already seen in the tutorial. So here we'll use another one step, and this is the cutout. So dimensions 220, 120, and this cutout is of 100 mm. So from this cutout 100 mm. So before that we'll we'll sketch out this. So I'm saying that this cutout is used to suck the air. So we'll pad this one for 55 mm. 55 mm is too much. We'll use the 50 firstly. After then, if required, we'll increase it. So this cutout is total. So we'll use cutout command here. So this pocket is completed. Now we'll use the fillet commands or a radius here. So where is that tool? Here. Oh, before that, the draft analysis is most important. So that is our today's agenda. So we'll apply the draft here, and in next video we'll moving towards the draft analysis. So here we'll use the 0.5 degree to 0.5 degree. So here the draft is get completed. So if you want to see how the draft works, so you can see that there is a difference between baseline and drafted line. So I'll define here and we'll give the radius here. So whatever you require, as per the requirement, you can give the radiuses. So this 2 mm. So, and this look like much more bigger than, that's why I use that. Okay, so this is 4 mm. And now it's looking better. So the basic shape is get completed. Let's will compare with our this product. So you can see this is the basic shape. So this get completed. Now we'll moving towards application of the strengthening ribs, and at the center area there is a curved rib, so we need to do that one also. So just quickly recap. So this is the basic shape, and after then we'll added this pocket or this step on the blower, and so that the basic blower shape is get completed. Now we'll add the bodies for curved ribs. So that those are the internal curved ribs. So whatever shape you require, you can design, or you can follow whatever already I designed here. So this will directly follow results. So we'll use the dimensions 20 mm. Yes, internal circle is a 40, and after then 20 the gap between two circles. So here the central circular ribs shape is get completed. Okay, and the central rib will add into another sketch. So here pad, so dimensions we need to give. So adjust as per the requirement. So we know that the central ribs are at the top side, so just we'll keep or we'll move the dimensions as per our requirement, or a limited limits will set the limits of the pad. Here is okay. Okay, so this is the 2 mm neutral fiber. Okay, so now we'll add that connecting rib. So definitely we are adding the ribs, but that should be connected with the surrounded wall of that particular cover. So this connecting rib is most important. So such kind of a central curved ribs or a central ribs you had seen in lot of applications, daily use applications also, where the electric appliances or the blower used in the electric appliances, and from that the air is going to be sucked. So those kind of a ribs are allow the air inside that particular application or inside that particular body, and also the ribs are protect the entities which coming through the air. So they are get protected, they are not allowed to enter such as the piece of any kind of a dust or anything. So those ribs are used for protection also. So here the central support rib is get completed, and this is the connecting rib normally, and so here we have to use such kind of a 12 or a 15 ribs complete cone profile. Before that we'll extract that particular curved surface here. So let's see whatever the shape or a surface as per your requirement you can design. Otherwise refer whatever I'm designing here. So we'll use a curve command here, and we'll provide whatever the dimensions as per the requirement. So here such kind of a curve, so it look like better, but we'll just use the dimensions 150, and also we'll give this these dimensions which is nearly 7 mm. Okay, so here the surface we need to create, so we'll go into the generative shape design and use the command that is rotate from the surfaces. So the surface rotation, give the axis 180, that is the 360. So here the curved shape is created. Now we'll um, come back into the part design. Here you can see we have the basic ribs. Here we'll apply the draft analysis. Why the draft is used? As usual, for making particular model manufacturable, so that particular design should be get out from the tools, injection molding tools. That's why the draft analysis is necessary. So whatever draft you require, so minimum 0.5 mm is a standard process to keep the 0.5 mm manufacturing draft. So here you can see the draft is get completed. So now we'll use the intersect command, but before that surface should convert into the thicken body, so that we'll use the curved body here, curved shape area, use 2 mm. So now there is no necessary of that surface, we'll hide it. And now here you can see, so that rib, so those two ribs are there, so we'll add one body where those two bodies are get added into that. So this top rib, we can give the top curved ribs here, and we'll add internal curved ribs and that supportive or a connected rib here. And after then, so that one rib we need to convert, or we need to complete con into 12, but before that we'll complete this operation. So you can see so this single rib is not sufficient, which is not giving proper support. That's why we are converted this 1 into the 12 by using the circular pattern command. So once we added this 12, 13, 14, whatever the requirement, then those ribs are going to be sustained against the load coming on that blower or whatever the air pressure coming. So now you can see that it's supportive design get completed. So here you can see the central air intake, and in between that air intake area, and in between that we added the protective supportive ribs here. So now the ribs are get completed, we'll hide it. Now the surrounded ribs on the total shape of that blower duct. So we'll start for that. So similar kind of a method we are using for designing this also, as we use for the top curve. So whatever dimensions or shape required you can give here. Otherwise you can refer the dimensions. So this should be it is not at the corner area, so we'll use 2 to 1 here. We required only at this area. Another one 160, 140, and one is 165. We'll see the 70. It look like somewhat bigger. 165, it's okay. So the process is as usual. We'll set the limit, we'll use the thickness, and and the neutral fiber here. So set whatever the limit you have and use the thickness 1.5 mm neutral fiber, and here the rib get completed. Now as usual the draft is most important, so directly we'll apply the draft here. As usual we are using the 0.5 mm draft, so draft get completed. Now again the supportive rib, that rib is most important, and that the outlet area we need to add some ribs here, so we'll start for that. So here we are adding the supportive ribs at the outlet area. So here the three ribs are added at that area, so it is totally depend upon the area of that particular duct or that particular outlet area. So here we had used almost 70 mm, so the 2 or 3 ribs are sufficient for providing the providing that support for the material. Somebody told me related to the sink mark effect. So definitely the rib thickness should be minimum that overall wall thickness. It is around 0.5 to 0.7 mm of your wall thickness, and such time there is no any sink mark will be occur in the future. So as overall wall thickness we will use as a 2 mm, so we'll kept our total ribs as a 1.5 mm. So at the sink mark is coming at the area where the wall thickness or a thickness is get increases, so that insufficient cooling is happen from the during the injection molding time, and that's why that particular defect is came. So in this next video or a next part of this video we'll use the manufacturing defects, probability of a manufacturing defect for this particular part. So follow the YouTube channel guys. So here the supportive central rib we are going to design. So dimensions and everything is just like similar we had drawn on the top side ribs. So thickness is 1.2 mm and the length is as per our requirement. So same way we'll apply the draft, so that selection of a pulling direction is same, because currently the tooling direction is the same. So pulling direction is nearly same as the tooling direction. So here the 12 supportive ribs we added, we need to extend this rib till to the end. Okay, so it's enough. So now the ribs almost get completed. Now only one point is get missed, I think, the duct area. So we'll increase the duct area, and for that we'll added one sketch here. So here 5 mm we added the thickness, extra thickness here, so we'll use the pad command 5 mm. We'll give the radius is 5 mm is not looking enough, so we'll convert it to the 10 also, but before that we'll add the proper radius 15 mm. So here you can see the duct areas get increases, we'll apply the connecting radiuses. So as usual, we'll use the 5, instead of 5 we'll convert that pad into the 10 mm. So it will be connecting area or end of that particular duct outlet area. So here we'll come back to the supportive rib command. So we'll added the total 3 ribs into the one single body, and after then we'll take a copy of particular blower shape, that is the main blower shape body. We'll take a copy paste as a result with link. After then definitely we'll need to add that intersect command we'll use, but before that thickness. So thickness we need to add. So here we'll apply the thickness as a 1.5 mm, and now we'll use the intersect command. So here again we can see, so we added 1.5 mm thickness, we'll use the intersect, and here the intersection is get completed. So now you can see 1.5 mm thickness ribs are get added. So just follow the Boolean operations for making the uniform thickness for the overall blower duct or a blower that cover. So here we added 1, 2 and 3 bodies. First body, that is the final body, so we'll rename it as a final blower housing or a final body, whatever name you want, just add here. Then as usual, we added one body, we removed one body. So first one is a, we can give the term as a positive and negative here. Either you can give the add body or a remove body, so whatever as per your convenience you can, or as per your understanding level you can give the name. So now this original shape is get added into the positive body, and copy of that particular shape body or a basic shape body will firstly paste copy as a result with link. After then we'll give the minus side thickness here. As I told, we'll use 2 mm, so overall wall thickness is 2 mm. Now this reduction of that particular wall thickness is added into the negative body. Positive body will just make a different, for differentiate we'll use some color code here. So for that positive body we'll use the pink, green. For negative body we'll add positive body into the final body, we'll remove the negative body from the final body, and after then the ribs are remains, but you can see the difference. So here we are going to add, so that top curved ribs are going to be add, and for these supportive ribs you can see they have some internal area also, so we need to add into the positive body. So this supportive rib is going to be added into the positive body. So ultimately that negative body will cover the internal removal of that area of that rib. So here 3D model design is completed. As I told, we are splitting this video or this task into the number of parts. So in the next part we'll moving towards the draft analysis, after then direction and manufacturing methodology, application and material selection for manufacturing purpose, then engineering features for assemble this particular blower housing or a cover, and after then the application of a GD&T to create the 2D manufacturing drawing. Guys, do not miss a single part of this tutorial, because we are started from the scrap, that is 3D model design. With respect to the consideration of a manufacturing feasibility, will end at the 2D manufacturing drawing. So this is very good opportunity to learn how the design is going to be done in the automobile engineering. Today's video is get completed. Thank you for watching our YouTube channel. We'll try to share more and more technical knowledge related to the plastic product design and Advance CATIA. But before that, you have to subscribe, like and share our videos, and do not forget to hit the bell icon. Thank you guys.